Subject refrigeration or and air conditioning. Today we are going to discuss unit number 2. Today we are going to take revision of it. So name of this subject chapter is vapor refrigeration system, and we are starting our lecture with the topic simple vapor absorption system. So before starting, I am just converting this document to another format. In simple vapor absorption system, we are always eliminating the compressor by uh, absorber, then generator and eliminator. So, um, in this vapor absorption refrigeration system, there is no compressor is present. Instead of compressor, we are using these three components. And the components like condenser, evaporator, receiver, throttling valves, these components are remain same whether in it is a vapor absorption system or whether it is vapor compression system. Here we are only replacing the generator with another three components, which is absorber, pump and generator here. So what are the function of these three, absorber, pump and generator? I already mentioned here. You can see on your screen. Yeah. Vapor absorption system. Vapor absorption refrigeration system. The compressor of a vapor compression refrigeration system is replaced by use of absorber, pump and generator. Absorber, it absorbs the refrigerant vapor by its weak solution in the suitable absorbent. Pump, it raises the pressure of rich solution received from absorber up to the condenser pressure. Then generator, it produces high pressure NH3 vapor. Here refrigerant, it is in the form of ammonia NH3, and we are using absorbent as water here. Here we are not directly compressing the NH3 vapor because the compressor required for NH3 high compressor work is required. So we eliminate the compressor and replace it by using absorber, pump and generator. Now we are going to see the working here. High pressure NH3 vapor from generator is passed to the condenser. In condenser, the vapor of ammonia is condensed. This high pressure liquid ammonia is then passed to the control valve, which is expansion valve. Expansion valve reduces the pressure of liquid ammonia and pass it to the evaporator. In evaporator, this liquid evaporates, and this low pressure vapor ammonia is allowed to mix and absorbs in absorbent with mixed solution of aqua ammonia and makes it into strong aqua ammonia solution. This strong aqua ammonia solution at low pressure from absorbent is pumped to the generator. Okay, and the generator, the strong aqua ammonia solution is heated and high pressure ammonia vapor are produced and cycle is continued there. Okay, I am going to again explain this working in the diagram here. Just look on it. We are starting here from this strong aqua ammonia solution. The strong aqua ammonia solution from this absorbent here, from this absorbent is absorbed by the its pressure is raised by the pump to the generator pressure. Okay, and in that generator, with the help of heating coil, what we are doing, this strong aqua ammonia, so from this strong aqua ammonia solution we are producing high pressure NH3 vapor. This high pressure NH3 vapor are moves toward the condenser, and after removal of this ammonia from this strong aqua ammonia solution, this aqua ammonia solution becomes weak, and this weak aqua ammonia solution is again we are passing it to the absorber one. Here you can see this is the absorber. We are passing this strong weak aqua ammonia solution to the absorber, and what is happening here I will tell you at the end of this cycle. Now we are coming here again. This high pressure NH3 vapor are moving toward the condenser. In condenser they are losing their heat, or we are cooling this high pressure vapor. And when these high pressure ammonia vapors are cooled at the condenser, there is a phase change occurs, and this ammonia vapor comes to the liquid form. You can see here high pressure liquid. This high pressure liquid, when passed through the expansion valve and when it comes to the evaporator, it suffers pressure drop, and because of this pressure drop its temperature also drops. And due to drop in temperature, when this vapor come in evaporator, it absorbs heat from the evaporator and phase change occurs. Means what happens, this low pressure NH3 liquid when comes in evaporator, it changes its phase, and this liquid becomes vapor. And when these vapors are again we are passing to the absorber, and at absorbers this vapor ammonia mixes with this weak aqua ammonia solution, and we are getting this strong aqua ammonia solution. This strong aqua ammonia solution is again absorbed by the pump, and pump again increase its pressure to the generator pressure. Okay, and again we are heating it to remove the high pressure NH3 vapor, and we are sending this NH3 vapor to the condenser here, and again this cycle continues. Now it's time to show you its video animation. I'm going to show you.
Today we will discuss about
A visible
vapor
animation.
absorption refrigeration system. Firstly, we will discuss about refrigeration. Lowering the temperature of an enclosed space by removing heat from that space and transferring this heat to elsewhere is called refrigeration. Refrigeration means extract heat from the space and lower the temperature of that required space is called refrigeration process. Firstly, we will discuss about parts of the vapor absorption refrigeration system. We have an evaporator, a condenser, expansion valve, and these are connected with the help of pipes, and a main component in the vapor absorption refrigeration system is vapor generator, absorber, and pump. In vapor compression system, there will be compressor instead of vapor generator, pump, and absorber. This is the main difference between vapor compression and vapor absorption refrigeration system. Evaporator is connected to the absorber with the help of pipe. Now we see the working of vapor absorption refrigeration system. What will happen? There in the absorber tank there will be ammonia and water. Ammonia will work as a refrigerant and water will be used as a absorbent. So absorber has both water and ammonia. Then this pump will pump this water and ammonia to the vapor generator, and in the vapor generator ammonia will convert it into vapor and water will come back to the absorber. Then these vapors will go to the condenser. High pressure ammonia vapor will reach to the condenser, and in the condenser they will lose their latent heat and convert it into liquid ammonia. and this liquid ammonia will reach to the expansion valve where reduction in pressure and temperature will take place, and this liquid ammonia plus vapor will go to the evaporator, and evaporator will extract heat from this liquid ammonia plus vapor and convert this liquid ammonia into completely vapor form, and this vapor form then go to the absorber again. So these low pressure vapor will go to the absorber and this cycle will repeat again and again. So this is the working of vapor absorption refrigeration system. Thank you for seeing this video. For more updated videos, you can subscribe.
I hope you understand the working of simple vapor absorption refrigeration system. Now we are going to see another topic. So we are again to this return to this topic here. So we are going to see this next topic, which is practical ammonia vapor absorption refrigeration system. So there are some additional part we are going to use here in practical vapor absorption system. So these parts are, you can see here, these additional parts are accumulator, uh, you can see here these additional parts are analyzer, then rectifier, then we are using this heat exchanger here, and again we are using heat exchanger here. So these are the extra parts which we are applying to use the ammonia vapor absorption refrigeration system in practical life. Okay, so taking discussing about these extra parts, I am already explained here that after the generator, if there are some liquid vapors going along with this ammonia via this way, by this upward way, then there is one component we are joining here, which is analyzer, which restricts the go of liquid refrigerant along with the vapor ammonia. It allows only vapors to go outside, and rectifier, it is again cross check that if any vapor, any liquid droplet is going along with the vapor ammonia, then rectifier eliminate it and again send it back to the analyzer by this way. And this heat exchanger, it is just using to improve the or to reduce the work of heat coil in the generator. It is just a heat exchanger. Similarly, here we are using this heat exchanger just to reduce the temperature of this liquid ammonia, or we can say that just we are using this heat exchanger to produce the subcooling effect. We again have this in written format also. You can see here analyzer. Analyzer. It is possible that ammonia vapor leaving the generator may contain some water vapor which will be condensed in the condenser. The condenser water may freeze in expansion valve and choke the flow. Therefore, it is necessary to remove this moisture. So, analyzer is just to remove the moisture from ammonia vapor before entering the condenser. Here there is some construction detail of this analyzer. An analyzer consists of a series of tray mounted over the generator. It acts as an open type heat exchanger. High pressure strong aqua solution from the absorber via aqua heat exchanger along with the condensate remove in rectifier flow downward over the tray, and it cools the hot rising ammonia vapor from the generator. Therefore, most of the water vapor gets condensed and drips back to the generator. This method helps in salvaging a part of the total heat energy from the NH3 vapor, which would otherwise have been rejected in the condenser. Then here is the another component, which is rectifier. A rectifier is a water cooled closed cooler. It helps in condensing the last traces of water. If any water particles which will not eliminated by analyzer, then for this rectifier is used as it is a cross check or double check. This unit ensures only hydrous ammonia, i.e. dry ammonia, reaches the condenser. Then aqua heat exchanger, there are two types heat exchangers. The aqua heat exchanger, in this heat exchanger the strong but cold aqua solution being pumped back from the absorber into the generator and is brought in contact with the weak and hot aqua ammonia solution. Here liquid vapor heat exchanger, it helps in reducing the temperature of the liquid ammonia in approaching the expansion valve so that an increased refrigerant effect is obtained in the evaporator. Okay. Now we are going to see this domestic Electrolux refrigeration system or three fluid system. You can see this three fluid system here, and the image of this system is here. This Electrolux refrigeration system does not require pump. So in this refrigeration system it contains generator, the system contains generator, then heat exchanger, this is the extra part, then absorber, then this is evaporator, condenser, and the water separator, which can be rectifier and analyzer. Okay. Look guys, in this system what you are seeing here, this is stresses of ammonia and water which is being pumped by this generator to the condenser. So what is happening here, here we are using water as a solvent and NH3 ammonia as a refrigerant. We are using NH3 as a refrigerant. Here what happens, absorber, this generator produces the ammonia plus water, high ammonia plus water. We will take this theoretical first, then I will explain this from this diagram here. So here we goes to read this domestic Electrolux refrigeration system, is also known as NH3H2 refrigeration system. The three fluid in this system are ammonia, hydrogen and water. Ammonia is used as a refrigerant. Hydrogen is used to increase the rate of evaporation of liquid ammonia. The water is used as a solvent for ammonia, and ammonia is used as a refrigerant here. Then working principle: the strong ammonia water solution from absorbent is heated in generator by using heat. By heating and high pressure ammonia vapor are created, which are passed to the condenser. A rectifier fitted before condenser to remove water from the ammonia vapor. The dry ammonia vapor are condensed in a condenser. The liquid refrigerant leaving condenser flows to evaporator where it meets the hydrogen gas. Hydrogen gas increases rate of evaporation of liquid ammonia. During this process of evaporation, the ammonia absorbs latent heat of evaporation from the evaporator and produces the cooling effect. Then the mixture of ammonia vapor and hydrogen is passed to the absorber where ammonia is absorbed in water while hydrogen flows back to the evaporator. Note here, in electrolux refrigeration system does not require pump, so it reduces the amount of power input. The flow of working fluid takes place by gravity itself. No expansion valve is used. So here we go on this diagram. So here what happens, we are starting from the generator and we will end on the generator itself. Here from the generator what happens is ammonia plus water, highly concentrated ammonia plus water vapor are available here. This ammonia plus water is passing to the water separator here. At this point water is get to be separated and only high pressure ammonia vapor is passed to the condenser. In condenser, this temperature of this high pressure ammonia vapor is reduced and this ammonia vapor is converted to liquid one. This liquid ammonia is passed to the evaporator here. Along this we are passing the hydrogen gas H2 here to the ammonia, because hydrogen enhances the process of evaporation of ammonia so that more heat is absorbed from the evaporator, producing the more cooling effect, and that's why the efficiency of system increases. So H2 is not taken directly part in the absorption of heat, it just enhances the capacity of ammonia to absorb heat from the evaporator. Now this ammonia plus hydrogen solution is then passed from the evaporator to the absorber. In absorber what happens, which H2 is get separated and it is again passed to the evaporator for the next cycle. Then this ammonia solution is this weak ammonia solution then in absorber what happens, the weak ammonia solution which is coming here from generator, this weak ammonia solution is coming in the absorber, it mixes with this ammonia vapor and becomes strong. This strong ammonia strong NH3 H2O is again passed to the generator. Here this is heat exchanger is uses just to remove just to reduce the work of heater. This working is not expected here, for your understanding purpose I am telling you what happened guys. Here after heating this strong solution coming out from this line, this strong solution it get heated, and because of this heating the ammonia along with the vapors are moving to the upward side. So this weak solution is already having much heat. So when it passed through this heat exchanger, this heat high heated weak solution is passes is heat to this strong solution, so that when this strong solution is moves to that generator, it is already heated, so that the heat supply by heating coil or fuel is less, then it uses less heat to evaporate and produce the high pressure produce the strong ammonia water solution there. So this is simple one, this is just for the increase the performance or to reduce the input given to the generator. For reducing purpose we are using the heat exchanger here. Now it's time to show you the how the actual Electrolux refrigeration system works.
Hello guys, welcome to my channel. In this video I am going to discuss the ammonia hydrogen Electrolux refrigeration system. So if you want to see more videos on refrigeration and air conditioning, you can subscribe to my channel. Let us begin. This is the simple diagram representing the Electrolux refrigeration system. The components here are the generator, rectifier, condenser, evaporator and absorber. Ammonia is used as a refrigerant because it possesses most desirable properties. Hydrogen used as to increase the evaporation rate of ammonia, as it is the lightest gas present, and water is used as a absorbent because it has the ability to absorb ammonia readily. So now let us begin with the process. A strong solution of H2O and NH3 solution is supplied heat. Here you can see in the generator from the gas burner, heat is supplied to H2O NH3 strong solution, and due to the difference in the boiling point of the two, the ammonia becomes vapor. Ammonia becomes vapor and rises to the condenser. Ammonia vapors. This rectifier checks that only ammonia vapors reaches the condenser, and the leftover weak solution is again recirculated in the cycle. Now from the condenser, this condenser is a gravity condenser, it moves to the evaporator, where the liquid ammonia is mixed with hydrogen. Now the hydrogen will make the evaporation rate faster, and ammonia and hydrogen solution will enter the absorber. In the absorber there will be water present there, so water and NH3 will combine together and hydrogen will be separated out and will be again recirculated in the cycle, and a strong solution will go pass through the absorber and again go to the generator, and from the generator the weak solution will be recirculated in the absorber, as I have said earlier, and the whole process will go on this way. Hope you have learned the cycle. If you want more videos on refrigeration and air conditioning, you can subscribe to my channel. Thank you.
So I hope you are getting this concept of this Electrolux refrigeration system. Similarly, we are having this another concept of this lithium bromide absorption system. So in this lithium bromide absorption system, in this system water is used as refrigerant, so it is uses for air conditioning only. In this LIBR is used as a absorbent, and the main components are generator, heat exchanger, absorber, solution pump, evaporator pump, condenser and evaporator. Boys, I already took this topic in the class and already explained this system for more than 2 lectures. So I'm expecting you already know this system very well. And here we are taking just revision only. So if you have any doubt, then you can message me personally or you can call me personally. So this is just overlook purpose. Generator and condenser are located in high pressure vessel and evaporator and absorber are located in low pressure vessel. Uh, Weak LIBR solution from absorber is circulated by solution pump to generator through the heat exchanger. Weak LIBR solution is heated by steam and or hot liquid is heated coil due to converted into water vapor leaving behind the strong solution and LIBR in the generators. Working is quite similar to the previous system, but only just refrigerant and absorber are changes here. The vapor refrigerant in condenser is condensed. The condensed water vapor at high pressure it goes to the pressure reducing valve where its pressure get reduced and it goes to the evaporator due to the pressure drop in temperature and also drop the in evaporator. This cool water is sprayed by evaporator pump on chilled water tubes which contain hot water from air conditioned space. During this hot water is chilled in tube and get converted into the chilled water. Therefore provides the required refrigeration load for air conditioning pressure and sprayed cool water in converter into the water vapor. This water vapor is absorbed by strong LIBR solution, sprayed in the absorber and convert it into the weak LIBR solution. Here you can see this schematic of this lithium bromide absorption refrigeration system. So here are the two chambers. It is low pressure chamber, it is high pressure chamber. In high pressure system generator and condenser are placed and in low pressure system absorber along with the evaporator are placed, and I already explained the working of these in this theoretical manner before this. Now it's time to show you the actual working of this lithium bromide absorption refrigeration system on the YouTube.
Welcome to my YouTube channel. In this video, I teach you lithium bromide vapor absorption refrigeration systems, which is the absorber, what is the refrigerants, its chemical. So, lithium bromide in the lithium bromide system, this lithium bromide is used as an absorber. So, its name suggests that the lithium bromide vapor absorption refrigeration system. So, lithium bromide is used as a absorber and water is used as a refrigerant.
I already
Now
tell you
lithium
the
bromide
same thing in
is
our
the
explanation.
corrosive in this nature. So when this lithium bromide is used, we need to add some inhalators in that, and this lithium bromide is mixed with the lithium bromides to make the lithium bromides anti-corrosives. Okay, so how to draw this diagram? So this is a simple system. Okay, that is the aqua ammonia system that you know knowing already. And if you don't know, then link is provided on the top right screen of your mobiles or the laptop. From the I symbol, you can watch this video. Now in that case, these are the different systems. That is absorbers, evaporators, generators, and condensers. But the schematic diagram for the lithium bromide system is different. So how that are making the cell? So in this lithium bromide system, the two cylindrical cell is made. One is the low pressure cell. So you know this evaporator and absorber have a low pressure inside that. So it is mixed in the one cell. Okay, so evaporator and absorber is put in this one cell, and the high pressure component, that is the generators and the condensers, are putting onto the another cell. So we have the two cell, that is a low pressure cell and a high pressure cell. In the low pressure cell, evaporator is there and absorbers. In the high pressure, generators and condensers. So I am moving to these another diagrams. Now in this component, these are our higher side, that is a higher pressure cell. In that is generators and condensers. and these lower pressure cell evaporators and absorbers. So water is refrigerant, lithium bromide is absorbers. Now another component is this refrigerating pump. This is the solution pump. This is the heat exchangers. Okay, so these are the mainly components. Which are component? Absorbers, evaporator, generator, condensers, refrigerating pump and solution pump, and one heat exchangers. And another tube connections. Now I explain you how to draw these tube connections. So it is the most confusing things for the students to how to draw this tube connection, because there is a number of the tubes. So this first is the evaporator tube. Okay, now this tube is contain the brine solutions. Okay, in this tube some brine solution is in, that is cooled in evaporators, and it is out, and then it is.
Hello guys, welcome to my channel. In this video I am going to discuss the
I hope you understand this. I hope you understand this concept, and if still you have the queries, you can call me personally on my number and you can message me. Now it's time to check another concept. So this is the Carnot refrigeration system. This is the basic refrigeration system which we are using in our this is the basic one. It is having efficiency 100%. So what is Carnot? It is having two isothermal process and two isentropic process, which is imaginary one. It is not occurs in practical life. Then we are going to see this TS and PV diagram of this vapor compression system. So this is the TS diagram and this is the PH diagram. You can see the explanation of this process. I already write it here. Process 1 to 2 is the isentropic compression. Uh, Processor 2 to 3 is isothermal heat removal or condensation process. Then process 3 to 4 is isenthalpic expansion process. You can see this isenthalpic expansion process. During the isenthalpic process, the H remains constant. That's why this 3 to 4 it is straight line here, and 4 to 1 it is the isothermal heat absorption or evaporation. Now advantages of VCR over Carnot cycle. VCR is smaller in size and having low running cost as compared to the Carnot cycle, and a Carnot cycle cannot be possible in practical. It is imaginary one. Now again the COP of vapor compression cycle is high as compared to the Carnot, and control over vapor compression refrigeration system is easy as compared to the Carnot cycle. The disadvantages of vapor compression refrigeration system is that its cost is high and is required greater safety. Now we should to see the next concept. Then this is the thermal analysis of our vapor compression refrigeration system. Thermal analysis means what we are going to there are the four different types. You can say that what all the different changes you can made. So first one is the when vapor is dry and saturated at the end of compression. Here you can see that how vapor, I already explained this in the class that this is critical point, and in that region it is subcooled region, it is superheated region, and this region is the wet region. Then how this evaporator is entered in compressor when it is superheated. Here wet refrigerant is entering the compressor and leaving the compressor in the form of saturated refrigerant. Here what happening, here the refrigerant entering the compressor is wet, as well as the refrigerant leaving the compressor is also wet one. Here what happening, the refrigerant entering in the compressor is superheated and refrigerant leaving the evaporator is also superheated. Here what happened, here we are producing the subcooling. How we are producing subcooling, what are its effects, I already mentioned here, you can read it. Okay. And we already spent much more time on this concept in the class itself. So here are again the type of this analysis, that effect of reduction in suction pressure. Suction pressure is here in bottom line. So here is a reduction in suction pressure and increase in discharge pressure. So you can see this, we are increasing the discharge pressure from 0.2 to 2 dash. So this is the increase in discharge pressure. So and effects is already written here, that work done on compressor increases, the refrigerating effect decreases, COP of the system also decreases. And effect of reducing suction pressure is that compressor work increases, refrigerating effect decreases, and coefficient of performance also decreases here. Now these are the methods of improvement in simple saturation vapor compression system. So there are the two methods by using the flash chamber. So there are two methods of increasing improvement of simple saturation vapor compression system. First one is by using the flash chamber, and second one is the by subcooling of liquid refrigerant. And in that by subcooling we are having again two types. First one is the by vapor refrigerant leaving evaporator, and type 2 is by liquid refrigerant from expansion. So how we are going to use this flash chamber? You can see this flash chamber here. I already tell you many time, when this liquid refrigerant passing from the condenser, it's when moves out of this expansion wall, maximum and 10% of this liquid refrigerant get flashes, and this flash vapor when moves to the evaporator, they does not absorb it, as it is already having their phase change, they are vapor. So that's why what we are doing, this vapor refrigerant or flash vapor, we are removing this vapor from the before entering it to the evaporator, so that only liquid is going to be entered in the evaporator, and it absorbs more heat, so that what will happen, more cooling effect is produced in the evaporator, and performance of this refrigeration system increases, and this removed flash vapor is passed to the compressor directly. So you can again read this information here, that what I am writing, a small quantity, nearly 10% of liquid refrigerant get evaporated flash as soon as it left the expansion wall due to pressure difference. This flash refrigerant does not produces any refrigeration effect after going to evaporator. So to remove this flash refrigerant, we are using flash chamber, so that flash is removed and only liquid refrigerant is supplied to the evaporator. This increases the refrigerating effect. Similarly, we can produce this by using producing the subcooling. You know, I already take this in thermal analysis of the cycle. By producing subcooling, this refrigerating effect is increases. You can see this, normally refrigerating effect is 4 to 1, but after producing subcooling of 3 to 3 dash, we are getting refrigerating effect from this 4 to 1. So you can see in this diagram also that refrigerating effect is increases. So there are two types by using the by vapor refrigerant leaving evaporator. Here what happens, the refrigerant vapor which are leaving this evaporator are its temperature is less than this liquid leaving the condenser. So to reduce the temperature of this liquid from here, to reduce the temperature of this liquid from 0.3 to 3 dash, what we are going to do, we are passing this vapor coming out of evaporator from this heat exchanger, and at this heat exchanger it absorbs heat from the liquid refrigerant, and this liquid refrigerant become subcooled from point 3 to 3 dash. Similarly, we can use another method, which is by liquid refrigerant from expansion valve. So this liquid refrigerant which is passed after expansion valve, we can pass it to the evaporator, and this also perform the same function of subcooling, and again we are passing it to the compressor. uh, we can use these two methods to improve the performance of vapor compression refrigeration cycle. Now these are the formulas which you guys uses in the uh, numerical. So what is this first formula? The first formula, heat rejected at condenser QC is equals to H2 minus H3. You know that process 1 to 2 takes place in compressor, process 2 to 3 takes place in condenser, process 3 to 4 it is isenthalpic process take place at expansion valve, and process 4 to 1 is evaporation, and it takes place in evaporator. So guys, some information is written here also, that HF3 is equals to HF4 plus X4 into HFG of 4, where X4 is dryness fraction. This Hg4 is enthalpy of evaporation. Enthalpy of evaporation, enthalpy of liquid, enthalpy of liquid at condenser, enthalpy of saturation is I already show you how they are going to given this data in the numerical, and how we are going to use. Then this is for refrigerating effect, which is H1 minus H4. Then COP, formula of COP is H1 minus H4 upon H2 minus H1. Similarly, COP actual, it is plant capacity upon compressor work. We are going to use this formula in numericals. So here are your numericals. Before this, again, these are the types of formula, that how we are going to calculate the enthalpy at various point, or enthalpy at exit of the compressor. So this is H1 is equals to H1 is equals to HF1, enthalpy of liquid plus dryness fraction is equal to the enthalpy of evaporation. We are using this formula when wet compression is occurs, or when the refrigerant entering the compressor is not dry and saturated. Similarly, this is type 2. If at entry of compressor the refrigerant is dry and saturated, at this time H1 is equals to H of G, and H2 is equals to Hg2 plus HF2 plus HFG2 plus Cp into T2 minus T2 dash. Like minor, the description of this is already I show you in this page also, you can read this. And similarly, next type, when refrigerant is superheated. For subcooling, when no subcooling performs, you have to use this condition in the numerical. This page is very much important. So this is the numericals, my child, which is the simple one. I take this numerical in the class also, and in our extra lecture also, when some students come to me for this extra lectures. A VCR refrigerant work on between 4.98 and 1.86 bar. The temperature of feather. So this is the uh, pressure at which the compressor and condenser are working, which is 4.98 and 1.86. Here again the information is stated that the liquid is subcooled to 9 degree, dry before compression. Means what it is, wet compression takes place. Dryness fraction is given as x is equals to 0.95. Okay. You can see here the point 1 is taken in the wet region. If they are telling that this refrigerant entering the compressor is dry and saturated, at that point we will take this point 1 on the saturation curve. But they are telling that our vapor is 95% dry, means it is 5% wet. So we are taking this point 1 in the wet region and start compressor like this. Okay. And also they are telling that the compressor there is subcooling is present. So how we understand that there is a subcooling is present? You can see that the numerical they are stating that the liquid is subcooled to 9 degree before throttling. Means what? Before throttling the subcooling is provided, which is 3 dash to 3. Now you can see that we are using this formula of H1 is equals to F HF1 plus Hx into HFG1. How we use this formula is explained in the previous page, that the conditions which I wrote there, just learn through it. And we are using this formula of H2, which you will get on that page. We are putting the value of there and calculate the formula. Similarly, we are using here the formula for COP, which is H1 minus H4. Putting the values, and we are getting the COP as 4.5. Now in examination the COP should be less than in the range of 4 to 8, should be less than 8. If your COP is coming as 50, 60, then consider then check your numerical again, and you will find something, because many the standard COP of vapor compressor refrigeration cycle is comes below 8. Similarly, we are taking this another numerical. Here what happens, this is again wet compression, and the vapor leaving the compressor as are dry and saturated, and here no subcooling is provided. So formula will be something changing there. We just have to use proper formula. Here again they are not providing us the dryness factor. Here they are not providing us the dryness factor. For this you need to find this dryness fraction. For this we are using this entropy. They are provided here S1 S2. Then we are finding this S1 S2, then comparing S1 S2 to finding the dryness fraction. Then this dryness fraction should become below the 100 below 1. Your dryness fraction should be 0.7 to 0.99. In that region your dryness fraction should be come. Then putting the value of dryness fraction in H1 H2 formula, and we are getting these values here. This is the third numerical which I took in your in class. Here what happens, here is the weight compression. Here is the weight compression performed along with the superheating, and no subcooling is provided here. This numerical is quite simple. Here just whenever there is a weight compression is provided, at this time you need to calculate the X dryness fraction. Sometimes X may be given in the examination. So dryness fraction is already given here, which is 0.96. So but here we are not having the value of that CPV. So to finding CPV we are equating this S1 is equals to S2, and then finding value of CPV, then finding the value of H2, value of H1 by here we are calculated the value of H1. Calculate the value of H2, we need the value of CPV. So after knowing the value of CPV, we are getting value of H2. Then here we are using the formula COP is equals to H1 minus H4 upon H2 minus H1. By putting the value, we are getting value as 4.97. I already told you that the value of COP should be less than 8. Same here is the rise in temperature they are asking. This formula is also easy one, not much more hard. Then these are the simplest form of formulas in our chapter number 2. There are a few types. You can see here that here you have to find out. They already give you these three temperature values, which are temperature of condenser, temperature of evaporator, and temperature of heater, then condenser, and temperature of refrigerant. From this three temperature you have to find out the values, and the formula is already given here, which is simple. COP of Carnot cycle is a T T minus TC minus E, and you have to use this formula to find out the answer. We already took three numericals related to this in our class. You can see on this that if there is some correction, then I already corrected it with pen. I hope you understand this chapter number 2, and if you have any queries, then you can contact me personally on my personal number. Or until now, stay home, stay safe, and hope to see you soon. In this chapter, they ask the one theory and one numerical question. So numericals are also easy one, not much more hard. So try to do both numerical along with theory. And this you initially say that this theory is quite difficult one, but if you practice it, if you understand the concept, then this theory is also easy. So not much more. And all teaches you this chapter in very much deep. If you refer the class books of some of your friends, then you will get to know. And if I think that the students who seated in class for the theory concept, they already know this concept and they understood it to bit effectively. So you can take help of them also. And also I want to tell you that if you goes to YouTube for understanding purpose, then this will also helps you. So try to do your best in exam.